Our learning target in this session is I can graph a quadratic function in factored form. So what do you need to know? This is an example of what factored form looks like. F of x equals a times x minus r sub 1 times the quantity of x minus r sub 2. Okay, the factored form has a subtraction sign in each set of parentheses. And if you remember from when we were solving our factored form, if I started in function notation and I'm starting in standard form, I'm going to kind of just show you a quick example of what we're doing here. Okay, so something like x squared plus 4x plus 4. So if I went to factor this, I'd end up with x plus 2 and x plus 2 as my factors. And if I want to find the solutions, I'd set those equal to 0. Notice this is the factored form of my standard equation where I'm starting from. Now a step further, r sub 1 and r sub 2 are the x-intercepts of the graph. So those are my solutions. Remember, we would take each of my binomials and set each of them equal to 0 to find my answer. So when I do that in this example, notice how I get x equals -2 when I move that 2 to the other side. So the R1 and R2, it's the opposite sign. Okay, so if you have a negative, it's really going to be a positive answer for your x-intercept, and if you have a positive, it's really going to be a negative when you have your x-intercept, because you have to move that constant to the other side to solve. So the A out front, that just tells us if we're opening upward or downward, just like in standard form. So if it's positive, we open upward. If it's negative, we open downward. The axis of symmetry is midway between the x-intercepts, and it has the equation of x equals r1 plus r2 all over 2. So we add our two x-intercepts together, divide by 2, and that's going to tell me what my axis of symmetry is. And then we plug the axis of symmetry into the function to find the y-coordinate of the vertex. So we take our answer for x and we plug it back in. Now, if we want to graph the factored form, first we need to factor if needed. So if we started in standard form, we could factor it to put it into factor form. Identify the x-intercept, and then we'd plot those points first. So once we've identified our x-intercepts, we plot those points. We determine the equation of the axis of symmetry, and we draw it as a dashed line. We plug in the axis of symmetry to find the y-coordinate of the vertex, and then plot the vertex. So first we're plotting our x-intercepts, then we're drawing our axis of symmetry, then we're going to plot our vertex. The fifth step is to sketch the graph, and it should be a U shape. All right, in this first example, we have f of x equals the quantity of x minus 2 all times the quantity of x minus 6. If you'll remember, our factored form looks something like this: x minus r1 and x minus r2. And like I mentioned before, whatever sign we have, the x-intercept is going to be the opposite sign, because when we go to solve, we set each of those binomials equal to 0. So our sign changes when we move that constant to the other side. Okay, so that's the reason for why it's gonna switch. So the x-intercepts here, I'm going to pull those out. I'm going to have the 2 and the 6. Those are my r1 and r2. So my x-intercepts written as coordinates are 2, 0 and 6, 0. The graph in this case is going to open up because I have a 1 out front, which is a positive value. My axis of symmetry, we use the equation r1 plus r2 all over 2. And my r's, those x-intercepts, were 2 and 6. So 2 plus 6 over 2. I'm going to have 8 over 2, which is going to simplify to 4. So my axis of symmetry is x equals 4. Now my vertex, I'm going to take what value I have for x, and I'm going to plug it into my function. So here you can see I'm going back up to my original function, and I'm substituting in 4 where I see an x. So 4 minus 2 all times 4 minus 6 leaves me with 2 times -2, or -4. So my vertex is going to be at 4, -4. That's going to be the minimum of my graph. So when I go to graph this, I'll show you what it looks like. Okay, if we refer to our rules, we can start by graphing our x-intercepts. So those are my points in yellow. Okay, so I graphed here at 2, 0, and I graphed another point here at 6, 0. We graphed our axis of symmetry. That was the line x equals 4. So this vertical line here is going through at x equals 4. Okay, that's that axis of symmetry. And notice how the axis of symmetry goes through the vertex. And my vertex is at 4, -4. So over 4, down 4. And then you can go ahead and just draw in your graph. So I'm just going to kind of trace over this so you can see, and it's always going to be that U shape when I'm drawing in my parabola. Okay, so example 2, now would be a great time for you to pause, try this one on your own, and come back and check. We're going to go ahead and take a look at our form. We have f of x equals the quantity of x plus 1 all times the quantity of x minus 3. So we see that this is in factored form. We have those two binomials here. And remember, our factored form looks like x minus r1 and x minus r2. So we're going to pull out those values for r1 and r2, and the signs are going to be opposite. So since I have that positive one there, I really have r as -1, and then on that second point, oops, I have it covered up there, sorry, is going to be 3, 0, okay, for my second x-intercept. Because I had a -3, when I go to solve that for 0, I end up with +3. Remember the reason we're getting these? We're setting that binomial x plus 1 equals 0, so when we subtract 1 from both sides, that's where we get that -1. Same with the x minus 3, I'll put that over here. Set equal to 0, I'm adding 3 to both sides to get x by itself, so x equals +3. That's why we flip the sign. Now, does the graph open up or down? So that's when we look out front of our function for that a term, and in this case, a is just +1, so it's going to open up. It's a positive value. Okay, the axis of symmetry, and in case you need a visual, this is what it means when it opens up. The axis of symmetry, we take our values of r1, and we add it to r2, and then we divide by 2. We're finding the midway point between our two x-intercepts. So I have -1 plus 3. Those were my two intercepts, all divided by 2. And that's just 2 over 2, or 1. Okay, so my axis of symmetry is at x equals 1. And then I need to find my vertex. So now that I have my value of x equals 1, I'm going to take that value and I'm going to plug it into my function. So I'm evaluating my function at f equals 1. F of 1 equals 1 plus 1, okay, because that was my x. I'm plugging in 1 for x. 1 plus 1 all times the quantity of 1 minus 3. So when I evaluate that, 1 plus 1 is 2, and then 1 minus 3 is -2. 2 times -2 is -4. So my point for my vertex is going to be at +1, -4. So we need to go ahead and we need to graph this, okay? So I'm going to start by graphing my x-intercepts. Okay, that's that -1, 0, and 3, 0. So I'm going to come over here in yellow, and I'm going to find -1, 0 right here. And I'm going to find 3, 0 over here. Okay, so there are my two, oh, come on. There's my 2 points that are on the x-axis, my x-intercepts. Now my axis of symmetry is going to go through at x equals 1. So I'm going to go ahead and draw in that axis of symmetry, and that's that dashed line that goes through right in the middle of my two x-intercepts. And notice how they're the same distance away. Okay, -1 is 1, 2 spots away from that axis of symmetry, and it's also 1, 2 away from my next x-intercept. That should always be the truth. And then the vertex is at 1, -4. So I'm going to go ahead and go over 1 and then down to -4. There is my vertex. And then we can go ahead and draw in our parabola from that vertex through those intercepts. And there I have my parabola. This topic of graphing in factored form, You can check out the Learning Target spreadsheet for additional resources, videos, and practice.